So if we look at the last section, like I said, we're going to be talking about double replacement reactions, and they typically occur in aqueous solutions. So in your lab, the two liquids that turn the bright yellow. So you had a yellow precipitate, a white precipitate, and a blue precipitate. We started with aqueous solutions, and ours produced precipitates. They can also produce water, or they can produce a gas, like your single replacement of hydrochloric acid and magnesium. So there's different things that can be produced, and that should make sense. So first question, what are aqueous solutions? You should already know that. What's an aqueous solution? Something mixed with water. It's in solution, it's mixed with water. Complete ionic and net ionic is what we're going to look at. That's going to be the main part of this. And then how can you predict whether it's a gas, a water, and there's your vocab. So aqueous solution contains dissolved substances. It's a solute. So when I make your calcium chloride solution, I go to my cabinet, I get solid calcium chloride, and I put it in water and I stir it up so it's dissolved. The calcium chloride would be the solute. It's in water, makes a solution. Usually most solutions will completely dissolve. Sometimes you'll have some that'll kind of settle at the bottom. My lead nitrate, you can see if I don't shake it up, it'll kind of settle, so it does not completely dissolve. Carbonates don't dissolve all that well, so I have a little bit at the bottom of my sodium carbonate. But when I have an aqueous solution, Spanish, aqua means water, water is always the solvent. That's what we use to dissolve it. Many solutes, sugar, alcohol, or compounds that can be put into solution. Anything that produces hydrogen ions are going to be acids. And we're mostly going to look at ionic compounds because they're going to split apart, and we'll look at that. So what happens here, when an ionic compound dissolves in water, their ions disassociate. They split apart. So when you drink Gatorade and it says that it has electrolytes in it, electrolyte and ion is pretty much the same thing. You need potassium ions in your body. You need sodium ions, you need chlorine ions. Where's an easy way to get sodium and chlorine ions at? Salt, sodium chloride. When you have sodium chloride, it gets into your bloodstream that has water, it dissociates, and you have sodium ions and you have chlorine ions. Without these ions, your muscles don't work well, your nervous system doesn't work well, and your body can't function correctly. So even though we're talking chemistry, ions are also very important in your human anatomy. And they advertise. Electrolytes are a huge thing in commercials right now. Ionic compounds can be solutes, so they can be the part that's dissolved. Same thing, dissociation, they're going to separate, dissociate. If I dissociate myself from you, that means I don't want to hang out with you. So dissociate means to split apart and not be together. When two different solutions that have ions are combined, then those ions can react in their own way. So that's going to be a double replacement reaction. Precipitate, water, and gas is usually the outcome when we have a double displacement reaction. I'm gonna come back to this, so I'm skipping that page for now. And I'm skipping that, and that, and that. Here, yay. And I'm skipping that. I will do this slide. Here we go. So we're towards the end. Here I want to show you, sometimes you can combine reactions. So if I have two reactions, and in my instructions it would say I'm combining them, I will take all of my reactants and put together. So now I have 3 reactants. And then I will take all of my products and put them together. So I am going to add everything together and put it, it's called a combined reaction. However, here, notice I have, so here's my overall combined everything. I have H2CO3 on this side, and I have it on that side. I'm going to simply eliminate that one. So I end up with my 2 reactants, and I end up with my 3 products that do not show up on both sides. So I can combine reactions. That doesn't happen very often. I will not have one of those on your test, but it's good to know, and there's one for you. So that's pretty much your notes. Here's your questions. I am going to stop, and we're going to go to a practice problem and actually go over everything that I kind of skipped in the middle. And then basically that will be your section 3 notes, and that'll cover the chapter.